All right, so now if I look at this, I know that the vertex, so this is the vertex form, right? This is the vertex form, and we're asked to take this equation and make it look like this, right? So that's the vertex, this is the standard form. And so A equals 5, B equals negative 30, and C equals 95. Okay. So the vertex form, the x-coordinate occurs at negative b all over 2 times a. So that would be negative 30, which is a positive, all over 2 times a, which is 5. So you got 30 over 10, which is just 3. Okay. Now, that's also the same value for h. Now, if I want to find k, remember that the vertex is written in x comma y. It's a point on the graph, but really it is the value of h, and then f of h, if you want to think of it, or h. Let me rewrite it this way: h comma k. So I just need to find the value of k by finding the value of y. Does that make sense? So I'm going to take this function y of 3. So I'm going to plug in 3. So I get 5 times the quantity, 3 squared minus 3. So wherever there's an x, I'm just plugging in 3. All right, so 3 squared is 9. 9 times 5 is 45. Then 3 times negative 30 is just negative 90 plus 95. So then if we follow order of operations, adding and subtracting just goes from left to right. So 45 minus 90 is just a negative 45 plus 95. And then lastly, 95 minus 45 is just 50. Now, y sub 3 is, or not y sub 3, y of 3 is actually the k value. So all this stuff is the k value. We don't need no stinking calculator. So my h comma k then is 3 comma 50. So to write this in vertex form, I'm starting to run out of room, but I'll come over here a little bit. For my vertex form, I'm going to say y is equal to a times x minus h squared plus k. So remember that what I'm going to write in blue is supposed to be the same thing as this mathematically. They're different versions of the equation, different forms of the equation, but mathematically they should have the same values. So I know what h and k are. I just found h and k. This is h, this is k. So I'm going to plug those in real quick. So I've got y equals a times x minus h, which is 3. Whoops. I don't know what happened there. Which is 3 squared plus k, which is 50. So if I find an x and y value that occur on the curve, I'm good to go. Well, remember that in standard form, c, which is equal to 95, is also the y-intercept. And the y-intercept occurs at 0, comma 95. So I'm going to let my x value be 0 and my y value be 95. In other words, I'm going to plug in 95 here, and then I'm going to plug in 0 for x. So 95 for y, 0 for x. And what you'll notice is that I have a bunch of numbers and one variable a, so I could solve for a. This becomes negative 3. Negative 3 squared is positive 9. So I get 9 times A plus 50. Subtract 50 from both sides. And I get 45 is equal to 9 times A. Divide by 9 on both sides, and I get 5 is equal to A. Whew, that's a lot of work. So then what is the final equation? Well, the final equation is going to be y is equal to a times x minus h squared plus k, where a is equal to 5, h is equal to 3, and k is equal to 50. So this is the actual, oops, this is the answer. That's it right there.